In this video, I'm going to explain how we find a confidence interval for a hypothesis test. In the problem, they're going to give you the same information that you're given in any hypothesis test. And you'll need to find the confidence level and then use the information given in order to compute the confidence interval. So here's how we solve these problems. In our problem, we're going to know the claim, and that's going to tell me what type of test that we're doing. We're also going to know the data or statistics, and we're going to be given a significance level alpha. If the problem involves a left or a right tail test, then our confidence level is going to be 1 minus 2 alpha, where alpha is our significance level. And if there's a two-tail test, then our confidence level is simply 1 minus alpha. So let's take a look at a problem and see how this works. A college professor wished to determine if the proportion of male students who passed a final exam is greater than the proportion of female students who passed the final exam. She found that out of 240 male students, 205 passed the final, and out of 260 female students, 210 passed the final. We're going to use a 0.02 significance level to find a confidence interval for the difference in the two proportions. So in order to do this, I'm going to start by determining the null and alternative hypotheses. And for that, I look to the claim. It said that the professor wished to determine if the proportion of male students who passed the final exam is greater than the proportion of female students who passed the final. So for my null hypothesis, I'm going to say that the proportion of male students is equal to the proportion of female students. And for the alternative hypothesis, I'm going to say that the proportion of male students is greater than the proportion of female students. So what this tells me is that this is a right tail test. So since our significance level is alpha, that means that alpha in this problem is 0.02. Well, what we know about our significance level, or alpha, is that that is the area in the tail. So since this is a right tail test, all of the value of alpha is in that right tail. So we have alpha equals 0.02 in the right-hand tail. But in this problem, we need to find a confidence interval. So when we're finding a confidence interval, we need the area in the center. So what I'm going to do is I'm going to duplicate this alpha equals 0.02 area on the left-hand side as well. And so that's where the 2 alpha comes in for a one-tail test. So I've got alpha over here being 0.02 as well. So now I have a total in the tails, total tail area is 0.04 or 4%. And what that tells me is that that leaves 96% for the center. So 0.96 or 96%. So my confidence level is 96 or 0.96, whichever one you want to use. So now we're going to find our 2-prop Z interval, and we're going to put in the data for the problem. So we're going to say for the males, let's see, we had X1 is 205, N1 is 240, X2 is 210, N2 is 260, and our confidence level is 96. And so once I do this, then I'll get my confidence interval for this problem. And I found that that confidence interval is negative 0.0221 to 0.1151. And so, since this interval includes the value 0, we can't conclude that there is a difference here, or that the proportion of male students is greater than the proportion of female students. So that's how I do that problem. Now let's look at a similar problem, but where we're doing a two-tail test rather than a one-tail test. Now this is essentially the same problem, but what I've changed here is the claim, and now it says that the proportion of male students who pass the final exam is different from the proportion of female students who pass the final exam. This means that the null hypothesis is that the proportion of male students is equal to the proportion of female students. And the alternative hypothesis is that the proportion of male students is not equal to the proportion of female students. So we've got a two-tail test here. All right, so since this is a two-tail test, look at our distribution. We've got alpha is 0.02 again, that's my significance level. But since this is a two-tail test, alpha is split between the two tails. So I have 0.01 in the right-hand tail and 0.01 in the left-hand tail. So altogether it makes 0.02. And what that tells me is that the area in the middle for this problem is 0.98. So I've got a confidence level of 98% or 0.98, whichever one you want to use. So when I do my confidence interval, all I'm going to change from the previous problem is I'm going to take the confidence level, which was 96%, and change that to 98%. And when I do that, my confidence interval is negative 0.0313 to 0.1242. So yet again, I cannot conclude that there is a difference between the proportions because this confidence interval contains the value 0. And that's how you create a confidence interval based off of a hypothesis test.